So it's time to introduce our first speaker for today, and that's Valentin Kononov. He will tell us about runtime type safety in TypeScript. And Valentin works at Mapbox R&D Center in Minsk, Belarus, and has experience in, among others, TypeScript, JavaScript, .NET, Angular, React, Node.js, NestJS, so a wide range of technologies. He loves the modern web technical stack, but strongly believes in understanding fundamental aspects of programming. He likes code writing, working on useful, valuable projects, and his spare time is mostly dedicated to his family, reading, writing, and traveling. So, without any further delay, I bring you Valentin.
Hi, everybody. Hi, Nicholas, and thanks a lot for such a warm introduction. And actually, I was a guy who entered Saratov here because it's a funny thing. I'm streaming right now from the Saratov from Russia. So I work for a company in Minsk, but right now for some political and geographical reasons, I'm located outside of Belarus right now. So
I see, fair enough.
I'm here.
Yeah, it's glad to have you. So I think you can go ahead and share your screen, and then we'll dive into your presentation. I'm super curious to hear about these concepts, and then I'll watch the YouTube chat for any questions that are coming up that we can pick up after your talk.
Sure. Thanks a lot, and let me start. So just once again, Nicholas and Prisma and Natalie, thanks a lot for invitation me here. It's an honor to me to be a part of the Berlin TypeScript Meetup. Actually, in the very beginning, when I just started to speak in these kind of events, I really, my wish was to be a part of pure TypeScript Meetup. And now I'm here. That's pretty cool. So my name is Valentin. I'm working mostly as a software developer, but I also had experience with the management stuff and a bunch of different interesting stuff. And basically, this talk is kind of my story of how I was developing software in different paradigms, how it was not convenient for me in some moments. So I'll talk about that and how I came to the concept of this runtime type safety, so why it bothers me. If you wanted to know more about myself, read some of my articles or my open source projects, you can go to GitHub Valentin Kononov or kononov.space. So most of the information is here, and my Twitter is also at Valentin Kononov. So before we start, just a couple of general slides about my activities in general. So I'm part of GDG Minsk community. We also do meetups for the web, mobile, and cloud technologies. It's a kind of small but very warm community, and I'm enjoying being part of it. And company I'm working in right now is Mapbox. We are doing a lot of mapping stuff, the navigation code, the map improvement, roads enrichment stuff, and a lot of things like that. And I'm a part of the project, which is preparing data for the neural networks for the user usage for roads enrichments. Very cool stuff. And let me start from also with a couple of questions. And the first question would be, why do you work with a TypeScript, not a pure JavaScript? I guess it's a valid question for the TypeScript community, and it will be really cool if you write a couple of words of your answer in the YouTube chat or right here, so anything. So why do you work with a TypeScript, not just a pure JavaScript? I'm asking this because I know a lot of people, developers, and just my friends who enjoy just the JavaScript and hate working with the TypeScript. But my whole talk today is about a different perspective on this thing. So it's interesting. What do you think about that? And also, it's very interesting what other languages do you use. So for example, the most not how to say it, not famous language which I tried is a Go language. Maybe it's famous right now, but it was absolutely new for me when I entered Mapbox. It's also interesting. And the last one, which is the most important question: what makes you feel safe when you write your code? What is that? So think about it and write these answers to YouTube chat. But we're going. And before we dive in, talking about the types and the TypeScript and stuff, I would like to just remind you how everything was started. Because without JavaScript, we would not have the TypeScript right now. And JavaScript was created in 1995 by Brendan Eich as a part of Netscape Navigator and Sun Microsystems. It was created in a very short period of time, like about 3 weeks. The first concept was created in about 3 weeks, and the primary target was to add interactivity to HTML. So it was created for designers to bring some life into static web. But it came out like that this saying is kind of famous all over the world. The world's most misunderstood programming language has become the world's most popular programming language. If you go to Stack Overflow researches, I believe that JavaScript would be the first, or maybe the second in some period of time, language. And of course, we all remember this kind of JavaScript tricks, like operations with different types would lead to different and sometimes unexpected results. I guess you all know that. I even wouldn't voice these things at the moment. But my favorite joke when I was just a young junior software engineer was this one, like, who wants to get 2 books, JavaScript for Dummies, 9 for each, 99 in total. It was just pretty cool stuff when we learn the JavaScript in my group. But God bless the TypeScript. Right now, we're living in the world where we can have the thing which I missed so much in a JavaScript, when we can have the compilation step. And this compilation step was given by TypeScript. Just a little piece of my personal story. I started as a C++ developer, and then I learned C#, and I worked like for years, more than 5 years, just with the C# development. And it was so hard for me to change that paradigm when I wanted to start some web development, when I wanted to start some JavaScript. I couldn't. I spent about a year, maybe more, just trying to convince myself that it's possible, you will do it. But only when I tried working with the TypeScript and Angular at that moment, I finally get that feeling that, okay, I know that this code is compiled and I know it's verified, at least on some level. So I can go on. I can move on with that. So the strongly typed and static TypeScript, I guess, gives this benefit for a lot of people. Another joke, which was also very popular in the time when I was the young student, like the compilation passing is already a huge result for us. So of course it's a joke, but you know, every joke has a piece of truth. So it's very important. And the TypeScript gave for me that feeling of safety, feeling like I'm at home, I guess because of this fact that the creator of the TypeScript is Anders Hellsberg, which is also creator of the C# before, and Delphi before, and Borland Pascal before. It's so amazing how much interesting and the industry-changing stuff was created by one person. So just a huge piece of appreciation. But it wouldn't be a cool language if it doesn't have things which can break it, right? So let's talk about the things which makes the step backward here, right? Let's talk about any. And everyone knows that TypeScript has any keyword as a kind of a backdoor for the JavaScript. Let's take a look to a short, simple example. If everybody knows that, that's awesome, but I will voice it anyway. So imagine the case. You have some object with some name, like name of movie is Game of Thrones, and you want to show it somewhere in the UI. You have a special function for it, which receives the object and shows something like a toast with a property name, with the value of name property. And imagine the case if at some point of time you understood that the word name is not so good for the movie title. It should be a title, and you change it. But if you didn't have types, so TypeScript consumes it is any object, and it will not give you any error at all. You will just keep working with that, but at some point of time you will see some undefined in the UI. Maybe QA specialist will find it, or maybe even customer. So to prevent it, you should just use interfaces, and it will give you that static analysis case. So TypeScript will understand what you are looking for and will warn you if something goes wrong. This is just awesome, very cool. If you just put a mistake, TypeScript compiler will check it for you and will remind you, hey, you should fix it before we go to production. And any is this kind of backdoor when you can escape these compilation steps and compilation checks. And if and basically you can even recreate all these JavaScript jokes, all these JavaScript tricks with the TypeScript if you use any. See, you can have the same, which is not so good. To avoid it, there is a couple of easy stuff. You can just correct your ESLint and your TS config files with special flags like no implicit any, no explicit any. And if you do that, which I really encourage you to do in every your project, which I also have, you will see the warnings. If you use any explicitly or implicitly, compiler will tell you, hey, something could be wrong here. This is a point, this is a place where you can have an error. So beware of it. But not just any can lead to that. There are a couple of other cases in the TypeScript which makes you feel not safe in both the compilation step and in runtime. And the first of these things is literal access for the properties. So you know that in a TypeScript and JavaScript, you can access the property not just by construction like dot, some name, but you can also use the string value and the square brackets to access it, the access value. And if you just use a string, there is no verification at all. But you can use the special construction, which is called keyOff in a TypeScript. And it will give you the safety of compilation verification step. So if you will try to put incorrect constant, which is not a part of actual keys of this object, TypeScript compiler will give you an error that there is no such kind of assignable parameter. So we're still talking about the static and the static part and what's happening before runtime. And closely, and finally, we will get to another point, the runtime. But I wanted to share a couple of other things. So some of you might heard about the yield construction, which is not so popular, but it's used in some cases for such so-called generator functions or iterator functions. And it's a very tricky thing. Before the TypeScript version 3.6, it didn't have type checks at all. So you could return anything in a yield, like in the example, and compiler will not warn you that something is wrong. After TypeScript version 3.6, you can specify the generic types for this function. And if you will do something wrong, for example, here I specified that return function is generator and the return value should have type number. And if something goes wrong, like in this example, you will see the compiler error. Just make sure that you use the correct TypeScript version first, and second, that you specify the return type with the generic parameters. This is very important, actually. And I also put in this here because of another example. Of course, we're not living in a world where we just have our code. It would be great, but it's not the case. In fact, we can have the dozens of different dependencies in our code. And in our project, we had a couple of cases with dependency to some libraries, for example, Redux Saga. It doesn't matter what this library does, but it does matter that we used this library with a yield keyword. And this select function, which we used for the working with the Redux state here, returned any. This is very important that when you use some dependent library which returns any for something, you should specifically set up the type for the variable when you get the returned result. Otherwise, your compiler will not have any chance to understand what's going on. It will just have any. So for this case, when select returns me any, I'm specifically putting the interface definition that I am receiving this task status value, for example. This is very important. And here is the actual code from this library. So just to prove the fact that it returns any. Make sure that when you're using some dependent libraries, you have either types in this library or you specify types on your side. Please help the compiler. This is very cool and important. And the last, the piece of the huge long intro is also about dependencies, but a little bit different type. We also use the cool and famous Ramp library, which is the library for the functional programming in a JavaScript and TypeScript. And you see the definition of the function which we used. The function is simple, pass or. You specify the pass, and you expect to receive either some default value or the actual value from the object. It's used in some functional programming cases. But take a look to the line of code number 4. There is this function expects any as an income. So it means that it will not check that pass which you sent here is correct. And this is the case for the refactoring issue. When you implement this function to access some property of some object, but then you change the interface, this function, and this piece of code will never know that you did it. So to avoid it, we added the special typings for this function. So like, in some libraries, you can add the special d.ts files. So we did the same for this particular library. And we specified that the pass is a generic one. So we don't expect just a sequence of strings. We expect sequence of key of something to help the compiler verify this for us. And in this case, we will have compilation issues if something went wrong. So summing up, just to sum up, we talked about any, literal property access, pure yield usage, and some other stuff like working with the dependencies and so on and so forth, how we can break our nice and beautiful TypeScript code. We also can have issues with backend and front-end calls when we physically don't have the things to verify that we receive what we expect. So, okay, everything is fine. What I'm talking about? I'm talking about that even if you make it work right on your local computer and everything is fine, it doesn't make you feel safe when someone else will use your library in runtime. Because especially when you write a library, you cannot be sure how this library will be used. And you cannot be sure that the person using it will not give you any object. So why is it happening? I always wonder why is it happening with this code, because you have the strongly typed static language. Let's take a look. You can implement a very simple function which has types as an income argument, and the return result also has type. It's just a multiplication. If you will mess up with argument types in your code, you will receive the compilation error. Everything is absolutely great. But let's take a look to the compilation result. As a result of compilation, you receive a JavaScript, and you can easily see that there is no types and there is no checks. And if the consumer of your code will try to break it and to use some other type or any object, you will not have a chance to fix it and to make it safe. Is there any solutions? Actually, I would be really glad if someone else will help me with the solutions apart from what I'm talking about. So please write your thoughts while I'm speaking in the chat of YouTube. The first solution which came to my mind is any kind of validation. So this is very cool when you work with the front end and back end communication, the API. You can just validate your request response. Also, you can write a lot of tests just to make sure that any corner cases will not break it. And also, you can add the manual checks for the most important cases when it's absolutely crucial. Yeah, type guards, cool. I continued to think, okay, I wanted to have the manual check for some special cases. And I have implemented this, like in this example. So if the type of what I'm receiving is not what I'm expecting, I'm throwing an error. This is perfectly work, but I don't want to have this solution all over my code because it will increase the amount of code, I don't know, 10 times. It's not cool. So can it be done so simple that anybody can use it, even my dog? I tried. I imagined that I would like to have a decorator, the really small, simple one, without any parameters, which you will be able to put on a function, and it will do all the magic. I need to say here that I'm a real fan of decorators. I know that it's not a common opinion that decorators in TypeScript is a cool stuff, but I'm really fond of it. I started to work with it in Angular, then in NestJS, and I really enjoy this declarative type. Yeah, and this was my dog, actually. So come on, let's move on. So I tried to implement this kind of decorator. It can look like this. So decorator basically in a TypeScript is just a function which will be called by the TypeScript, actually by the JavaScript code. So we will see a sample a little bit later. This function receives some arguments like property name, which will be the name of the function where you put this decorator. And also it has the important thing, the descriptor, which allows you to get access to initial function which you wrapped with the decorator. It's a cool stuff because you can do whatever you want with this function. For example, you can override it, and you can put any check types code here, and then if everything is fine and types are correct, you can apply this function and just return a result. So let's take a look about the checking types code. This piece of example is huge, so you don't need to read it really through. Just take a look on a couple of things. So first of all, if you are using the decorators, you have access in a TypeScript to a special library called reflect, and there is a function get metadata. And this is the metadata for the classes and for the classes parts like functions or fields or anything like that. And you can get access to it in a runtime. So if in a runtime, you can get the list of parameters for this function as you write it in a TypeScript code. So in a JavaScript, you will not have this types, but if you use decorators, you can have it, and you can get it from metadata. And also, of course, you have access to a variable called arguments. It's just a pure JavaScript variable which gives you an access to current function arguments. And you can just iterate all over it and compare, is the actual type equals to what you expect or not? And if not, you can throw an error. Of course, there are some limitations. So you can check for some primitive types like number, string, date, and is it object? Yeah, is it array? But you cannot have the checks for the array member types just because of limitation of TypeScript get metadata. And there are some other limitations. So you can have the checks of the class name, but you don't have the name of interface. So some issues are here just based on the nature of this get metadata library. So let's take a look. If you put this decorator for the function in a TypeScript, the final JavaScript after compilation will look like this. So basically, you can literally see what arguments are put in this decorator function. So the JavaScript, the TypeScript compiler will put these arguments for you. So you will not need to bother about it. It will be just in a compilation stuff. And you can see that expected parameters are list of numbers, 2 numbers, and the return type is number. And you can see the name of a function. So you have most of instruments, most of tools you need here. To demonstrate the feasibility of this concept and of this idea, I created the small NPM package. It's called TS Stronger Types, and you can download it and try it. And of course, there is an open source code for it with more checks, with some tests and stuff like that. Of course, as I mentioned, with some potential issues that you physically cannot check all the types, but still. And actually, this logo was drawn by my elder daughter. It's also pretty cool to have such family projects. What other options? While I was speaking, I took a look at the comments in the chat, and Sergey Velik mentioned IOTS. And this is the first alternative which I wanted to mention. So thanks, Sergey. IOTS is a cool library which will give you the same safety, nearly the same, maybe even better for the runtime. But the limitation for some people would be that you should use the special constructed types from this library. So you're not allowed to use just the pure classes of a TypeScript and interfaces or stuff like that. So all the safety, all the checks are achieved by using the special classes. So it could be a good choice for the small internal project, for example, which is very important. But if you are writing the library, or maybe you already have the big project, transition to such kind of library might be huge work as far as I think about it. Apart from that, there is another library called Superstruct TS Transformer, which is used to validate your requests or responses. It's cool to use, for example, when you write an API, and when you have when you want to have the straightforward way to check that incoming or outgoing JSON is a correct type, and it has all the needed stuff. And the most important for me and the coolest stuff is the class validators library. It's cool because, as I mentioned, I'm a fan of decorators in TypeScript, but not just because of it. It's also a big and important part of the NestJS framework, which is written on a TypeScript with the decorators. So it's the pure vision of how declarative programming should be. So you create a class, and you literally put the like a comment, this field should be a string, or this field should have minimum value as a 0. This field should be email. And when the API receives this as a request, and if the validation of incoming request is turned on, all these validations will happen automatically. So you will not see the point when this validation is called, but you will have it. It's very cool for some reasons. I think I'm coming to the end of this presentation, and here is some links. So if you wanted to have this slide, yeah, it might be called class validator. I might have some issues, so sorry for that. So basically, the links for this slide is here. The link for a GitHub repository with my concept is here. I've also written an article talking about the same, but with a little bit more details about the decorators and a little bit more history dive in. There is also a link here to my site and to NPM package. So if you try it, please let me know your feedback. You can just post an issue with the feedback or with the issue, anything you want. I will really appreciate it. And as a conclusion, so my point of this presentation and the mission of this library is to make you think a little bit more about your code as some kind of life stuff. you not just write it and let it away. You write it and it lives your own life after that. So it functions in runtime. And I really encourage you to think about what happens in runtime. It's really, really important. So that's why it's also important to make your code predictable and easy to read, and to put a lot of tests, as much as you can. And of course, to use types and validation wherever you can. If you use a TypeScript, but you don't use the benefits of types, I don't know, you fight with the TypeScript, and this is not cool. So try to use the benefits of it. The whole purpose of a TypeScript is to help and to make you feel safe. So the whole purpose of my talk is the same. So feel safe and enjoy your well-written code. Thanks a lot, guys.
Thank you so much, Valentin. I think that was a really, really insightful talk. At least for me, I have to say, I learned a lot when you talked about how decorators actually work under the hood. That was always something that I've actually wondered, because I've never used them from like a developer perspective and only from a user's perspective. So that was certainly enlightening. All right. I don't think that there were too many questions in the chat. One from Enrico is, isn't using validators that throw runtime errors in order to avoid runtime errors lots of hassle for not so much value? What's your take on this, Valentin?
As I mentioned, the whole purpose of this library and this idea was to demonstrate the possibility that the TypeScript language and all this stuff can make a step forward to the more strongly typed languages like a C#, even if in a runtime. Of course, I understand that it's not for every possible case. And if you just working with the API, of course, you might not need it. For API, you just need to validate the incoming requests, and that's it. That is fine. But if you are working on a library which will be used by some other people, and you are not responsible for how they will use it, and they can mess up with the types, for some specific cases, this may be, I guess, a good idea.
All right. Thank you so much. Oh, actually, there is now another question coming in that we still have time for. So I'll just show it. How runtime types errors can still occur if the compilation and the right use of TypeScript should have it covered at build time?
Yeah, as I mentioned, so even if you covered all your code with the types and everything's fine and compilation passed well, and even if you don't use any, but your code is used by someone else, like it is a library, for example, the consumer of your code can pass you any object or wrap some incorrect typed object with any, and he or she will receive some issues which is unpredictable. So if you want to make your code safe from these cases, you should just check that the types in runtime when the calls happens are correct. So that was the purpose.
Yes, and don't use any. You heard it here first, folks.
Yeah.
All right, Valentin, thank you so much for this talk, and we'll let you go now and continue with the other talks. But first, we'll enter the quiz question. So it was great having you, Valentin.
Thanks a lot.
Bye-bye.